Let's keep making more complicated kinds of programs to see how the design recipe works out. And as our next example, let's say that we were interested in programs over a GUI. So our GUIs will have labels like this, like pick a fruit. They'll have some choice items like apple, banana, or coconut, where we can select one of the choices. We'll have some buttons like OK and cancel here, so we care about the name of the button and whether it's enabled or not. And the kinds of programs we might want to write are you allowed to click a certain button right now, find a certain label on the screen, or read me all the text that you see on the screen. So again, labels, buttons, and lists are the kinds of things we have here. For labels, it seems like we care about the name on the label. For buttons, we're going to care about the name and also whether it's enabled or not. And for list, we have these different choices. Sure sounds like a list of strings, but also we need to keep track of which item is currently selected in that list. So let's go write some code as the representation step. We have a type GUI with 3 choices, which are label, button, or one of those choice boxes, list boxes. Okay. For a label, all we care about is the text of the label, which we can represent as a string. For a button, we also have text for the label, which we can represent as a string, but then we need to know whether it's enabled or not. So let's use a Boolean to do that. For a choice, we have a list of items, each of which is a string, and then we also need to know which one is selected. We can just use an integer counting from 0 to represent that. So that's a sensible choice of data type to represent these things. For example, if I just want to represent the GUI that has a hello world label, it would be like that. Well, hello world. Here is a button that says OK and is currently enabled. And here's a choice that lets us pick between apple, banana, and coconut, where currently we have apple picked, say. Okay. Now these are not examples of writing a program, but they are examples of the data. It runs right now, but that was just the first step of our design recipe. So for the next step, given this implementation of the data, let's suppose we're implementing read screen, which takes a GUI and returns all the strings for the GUI element labels. So the function is read screen. It's going to take a GUI, which we'll call G, and it should return a list of strings for all the text that it's on the screen. And it might be tempting to go write that function right now, but we're going to follow the recipe and go on to the example step. So we're writing examples using check of read screen. And when we call read screen, we provide a GUI. There are 3 different ways to produce GUIs. Of course, we've written 3 different ways down here, so we can just use those as our examples. So we can consider that example, and then let's just do this again for the button example, and again for the choice example. Okay, when we have just the label hello world on the screen and we read all the labels off, well, then that will be the only label we get is hello world. In the OK button case, again, it's just the OK button, so we just get OK. And in the choice case, though, we have 3 different things on the screen, apple, banana, coconut, so those should show up in our result as well. Okay. Now at this point, I can try to run it. I've got a little problem here. Okay, you may notice I used 4 dots here, and that's why I'm allowed to run it, but all the checks fail just by saying there's an incomplete expression. So you can use 4 dots to mean you're going to fill it in later. Typically your test won't work. They shouldn't work until you actually fill it in. Okay, those are our 3 examples. We don't have any other boundary cases to consider, really. We've covered all 3 cases, so maybe that's enough examples. The template step now says that we want to use match on a GUI G, which can be either a label that has some text, or it can be a button which has some text and whether it's enabled, or it's a choice which has some items and whether it's selected. In the case of a label with text, we have the text to work with. That's just a string, so we probably don't need a helper function for that. It's not a separate data type. Similarly, we have text and is enabled to work with here. And in the last case, we have items and selected. Now, items is a list of string, and so the template says you might want to have some helper function to deal with that list. With a little bit of foresight here, though, we can see that all we want to do with this list is just use that list. So the template would tell us to put read list here, but it turns out we're not going to need it. I'm going to keep a copy of this template just for the record, okay, demonstrating that this is what we got from the template step. And now I can fill in the body part based on the example. So I'm on to the body step of the recipe. T corresponds to hello world. We're trying to get a list containing hello world. So that looks like a list containing T is the answer. Similarly, in button, we've got OK and true. Turns out we don't need the true. We just need the button name. And again, that's in a list. And then for the last one, we will notice that we just want that list of items there. This is a bad name. Let's call it items. Okay. And we've considered all the cases separately. It's matched up for our different examples, and we can see that all the tests pass. So that's how we would follow the recipe to implement this read screen function.